welcome to the lecture series of Internet and Web Technology. In previous class, we have discussed about the IP address and IP address using classful addressing. The problems of the classful addressing are, in this lecture we will discuss about the problems of the classful IP addressing and another new technique, that is classless interdomain routing, then its notations and rules for forming CIDR blocks, and the difference between the classful and classless interdomain routing. We know that any device in the internet uses some IP address. To present those IP address, we are in past we are using classful IP addressing. In that there are several classes, class A to class C. Generally we are using class A, class B and class C. The problems of the classful IP addressings are, several problems are there. The main problems are, in that classful IP addressing, the inefficient allocations are done. Means every classes are fixed in size. If an organization wants, let's take an example, if an organization requires 2000 numbers of addresses, we are giving the class B network, but the size of the class B network is 65,536. Here 65,536 class B size, 65,536. If a organization needs only 2000 numbers of IP address, rest amount of IP addresses are wasted. Matlab 63,536 numbers of IP address are wasted, or we can use in different, we cannot use in different, so address are wasted. And due to this, the limited IP addresses are there, so address scarcities are happening. To overcome these problems, nowadays we are using a technique that is known as classless interdomain routing, or CIDR. CIDR stands for classless interdomain routing. If we go to its history, in 1993 it is developed by the Internet Engineering Task Force, IETF. Nowadays IANA, Internet Assigned Number Authority, allocates all IP addresses using this scheme. In this case, what happens? Now, if any organization needs 2000 numbers of IP addresses, it will provide exact amount of IP addresses to that organization. Due to this, the IP addresses are not wasted. We can betterly use that IP addresses. How we can represent the CIDR or CIDR notation? Exactly, we are using CIDR notation by putting a slash after the IP address. Let here its syntax is, its format is, we will write IP addresses in dotted decimal format, then put a prefix length or routing prefix. We are in dotted decimal format, we are writing A.B.C.D in this format, then put a slash, then this put a n, means A.B.C.D/n. Here n is the routing prefix or prefix length. It denotes, n denotes the length of the network ID. Length of the network ID means, take an example here. If we are writing any IP address, any block of IP address 192.168.1.0/24, this is a CIDR notation of any block of IP address. It means 24 bits. These 24 bits denotes the network ID. Means total length is IPv4. In IPv4, the total length is 32 bit. Here we are using 24 bit for network ID. Rest 8 bits are used for the host ID. Next 8 bits are used for the host ID. To form a block, CIDR block, we have to follow 3 rules. First rule means in that blocks all IP addresses are consecutive, means they are sequence in nature. Second is the size of the block should be power of 2, means 2 to the power n. 2 to the power n, because it is, if we take 2 to the power n or power of 2, it is easier to divide the network and block ID calculation. Example, for an example, if a block size is 25, means we can take 5 bits for host ID and 27 bits for the network ID. Then third rule is the first IP address of that block should be divisible by the block size. The first IP address of that block should be divisible by the block size. These are the 3 rules. Take an example. Take a problem. Let in a CIDR representation, that is 20.10.30.35/27, we have to find the range of that IP address in CIDR block. Give how we will solve? It may come in the examination, in many competitive examinations. How we can solve? Now here given is IP address is CIDR notation में 10.30.35/27. Here 27 is the n prefix length, means it represents the number of net ID. So number of host ID is equal to 32 minus 27, that is 5. So the first, so means the host number of host IDs are 5. In this case, the first IP address should be, we will put 5 zeros, because these 5 bits are reserved for the host ID. In last IP address should be, everything we will write, in last 5 bits should be all ones. If we convert to the dotted decimal format, it will be converted to 20.10.30.32, the starting IP address of that block. In the last IP address of that block is 20.10.30.63. Is it clear? Next, we will solve another type of problem. Then that is, consider a block of IP address from 100.10.2.32 to 100.1.2.47. The range is given here. Question is it is a CIDR block? Second question is, if yes, give the CIDR representation. We will check whether it is a CIDR block or not. How we can check? Now we know that to become a CIDR block, we have to follow 3 rules. First rule is all the IP address of that block should be consecutive. Second is the size of the block should be power of 2, and third is the first IP address should be divisible by the size of that block. If all these 3 rules will applicable in this, then we can say that it is a valid CIDR. Then check first rule number 1, that is it a consecutive? Yes, it is a consecutive, because it is written here 100.10.2.32 to 100.1.2.47. It means all are IP addresses are consecutive. Go to the rule number 2. In rule number 2, find out its size. Its size is if we subtract from the last IP address to have first IP address, we will get 47 minus 32. It is plus 1. If the number is equal to 16, numbers of IP addresses are there 16. We know that 16 is the power of 2, means 2 to the power 4. Then we will check the rule number 3. In rule number 3, the first IP address must be divisible by the size of the block. Means the first IP address is here 100.1.2.32 must be divisible by the 2 to the power 4. How we can check whether it is divisible or not? If the first here number of host IDs are 4, if we convert the first IP address into binary notation, if all the host bits are 0, then we can say that it is divisible by the size of that block. Here the first IP address is 100.1.2.32. If we convert into the binary, it is like this. It is here last host bits are 5 bits are 0, 0, 0, 0 and 0. So it is divisible by that block by 16 or 2 to the power 4. So as it follows or it satisfies all the 3 rules, so it is a valid CIDR block. The next question is if S, find its representation. The size of the block is 2 to the power 4, means 4 bits is required for the host ID. So how many bits are required for the net ID? Means 32 minus 4, that is 28. Then we will write this first ID 100.1.2.32/28. Then we will get the representation of that. Then at last we will classify what is the difference between the classful addressing and CIDR or classless inter-domain routing. In classful addressing, every IP address is divided into 5 blocks. Generally, broadly it is divided in 3 A, B, C classes, generally used. Rest D, E are special used. But in this case, we are represent in prefix length, IP address / mask. Then it is fixed subnet mask based on class. Here we are using variable length subnet mask, VLSM. Next, it is inefficient in most of the cases, but it is CIDR is efficient in most of the cases, because efficient means no wastage of IP addresses are there. Here routing table size is large. In CIDR the size of the routing table is small. If we summarize the entire thing, CIDR reduces the address scarcity and address wastage, and finally CIDR motivate us to use a limited pool of IP address in a better way. Thank you.